have the pleasure of having Dokyun Lee with us today. He is an extraordinarily productive scholar. If any of you are keeping track, he writes about a wide variety of topics, everything, but a lot of them with direct business applications to major firms like Airbnb and Uber. He's just been one of the more creative and frontier stretching researchers in the last half decade. And so it's a real pleasure to have him here and see what he has to say today. So thank you. Take it away.
Thank you so much, Shane. That's a really great introduction. Hopefully, this talk is somewhat interesting. So I am honored to be here. Thanks for having me. And I would like to present just a bit of a conditionals on this. This is a very, very new sort of like paper. So any feedback is welcome. And also the format, please feel free to interrupt me at any time. Any feedback or questions appreciated. So this is a joint work with my doctoral student Zhaoqi Cheng and Sunny Tambe at UPenn. So it's titled Innovae, Using Generative AI to Identify Breakthrough Innovation. I just changed that, we'll see. So just so that you have an idea where I'm coming from, I study the application development and impact of AI in digital consumer and e-commerce analytics. Two current focus is economics of unstructured data, or text and images, in different settings, and interpretable machine learning for business. So I do run a business insights through text lab or bit lab, where we attack questions on e-commerce related stuff, social media, innovation, persuasion, promotion scheduling, and so on. Today, I'll be talking about innovation or use of patent data. So one of the most discussed technological innovation and general purpose technology is AI. And AI has been presented as a tech to create tech or invention of method of invention. And we're seeing some successful application recently of AI in creative tasks, such as composing music, drawing paintings, and searching novel molecules. A few months ago, there was an announcement from DeepMind on AlphaFold 2, which claims to solve protein folding prediction problem to advance further innovation in biology. Right? These tasks were commonly categorized as work of creativity and traditionally believed to require human intelligence, but slowly AI is beginning to encroach on creative and inventive space. And we're not automating these anytime soon. The automation is far away, in my opinion, and no one knows, in fact. But in fact, many fundamental questions related to topic of AI for innovation and creative tasks remain unsettled. Even the definition of creativity is heatedly debated. But AI to augment the invention, augment and not automate, new technology is ripe for serious discussion. So this paper is basically an exploration into that. It's very early stage, but there has been a rising number of companies developing AI tools to augment scientific discovery. For example, Schrödinger and Atomwise are example companies that aid drug discovery or molecule discovery by finding candidate molecules and compounds and then running physics engine model and applying generative models as well as discriminative models to predict useful molecules for drug development. Right? So we also see a rise of number in papers published in top journals in different fields of science, like material science and things like that, that utilize deep learning and generative models. So, computation, despite the broad success of AI in these creative endeavors, the capacity of AI to introduce new idea or to innovate remains a subject of inquiry and debate.
And so, DK, can I just jump in here? So I want to get a feel for this. So I'm trying to understand, like, the straw man you're putting up here. Like, it seems like the null hypothesis is like a little bit wonky when should it be that AI can't be useful at all in innovation? I mean, it seems like wherever data might be helpful in innovation. And so in the past, we use other pattern recognizers. Like, this is just another pattern recognizer. So it'd almost be like, I'm not sure anyone would argue, okay, there's no stage or there's no aspect or attribute of innovation where AI could not be helpful. Like, I'm just trying to understand what you're trying to prove the other side of, right? And saying, oh, could it be helpful? Like, is anyone making the argument it couldn't be helpful at all, or?
No, I'm making, this paper is about augmenting, creative endeavors. I'm not saying, so the fully automation of it is probably hard at this point, but this entire paper is about, yes, generative model and deep learning is useful in creative endeavors and innovation.
Yeah, I'm saying were people arguing that it could not be useful? I'm just saying, I thought like most people's priors would be like, wow, data could help with parts of innovation, right? And it's been shown that data could help. And so in the past where we might use a regression, we might use a correlation, the point is if I just think about this is like, oh, this is another tool to analyze data. I'm not sure people's prior walking in would be like, oh, AI can't be helpful at all. So is that what you're trying to disprove? Is this prior that it can't be helpful at all?
Well, yeah, I mean, I'm getting to this computational creativity. There's some school of thought that still think it's not helpful at all. So this is
okay. There is a school of thought, yeah, that says zero. That has zero value add. Okay.
Yes, for creative endeavors. So in fact,
Lauren, if I can even add that some people, I was just in a discussion, are thinking that it's kind of wrong, that it's beyond even whether there is value or not, that we should not even do that. So I was just in a discussion on that it's wrong to bring AI into creativity. We should like guard it from technology, from AI specifically. So continue.
Really, okay, it's wrong to bring it in, but it's okay to bring in. So just so I understand, so this is interesting. Like it's okay to bring in regression. It's okay to bring in these other tools, which are quite similar pattern recognizers, but they put a bright line in the sand at AI.
I'll wait for the discussion. I'll wait for the Q&A to continue this, but okay. I'm curious to see what Dokyun has to say, but definitely there are people out there that are against it.
Yeah, I know this is like literally currently a heated debate topic. So, whether AI can have a capacity to innovate, you bring up a great point. It remains a subject of inquiry and debate, heavy debate. And it's a complex question, so I think humanity have begun to explore. Although computational creativity has been around for decades, it's just with the new generative models, it's becoming more heated these days. So as rightly pointed out by a few folks here, there is one school of thought that basically, unresolved arguments remain where one side claims machines neither cannot be creative nor identify creativity, and that should ultimately be left to humans as it requires intention. I mean, this is another like literal whole philosophy of creativity and philosophy of AI, but I don't have time to go into that. But the other side argued that we can start somewhere and provide some framework and definitions. I'm more along the second school, and that is the field of computational creativity, which has been thriving recently with the advances in neural network generative models. Right, so philosophy of creativity literature argue that before an intelligent agent or algorithm can generate a creative artifact, it must be able to distinguish what is creative or not, an ability that typically requires proper representation and an understanding of data. And in other words, to create innovation, AI needs to first recognize innovation. And we say before AI can recognize innovation, it should be able to represent innovation. And this entire paper is about us prototyping way to represent innovation, which is embodied by patents. Okay? So research question here is we prototype what we call Innovae to estimate the centennial representation of patents using both structured and unstructured data. So what I mean by the centennial representation, which is used, it's generated via generative deep learning model, is that it maps any real-world object, it could be multimodal, into any low-dimensional vector space. However, each dimension in this vector space is extracted such that one, it's statistically more independent, meaning it's semantically more orthogonal. I'll get into what I mean exactly what I mean by that. And second, because it situates these objects, like in my case, patents, in a vector space where the movements within the space are rendered meaningful and understandable. So interpretability and independence of dimensions is the key point here. So what is a disentangled representation? Let me give you I know a lot of people may be familiar with this already, but just so that we're on the same page. Disentangled representation learning is basically given set of data. It's trying to come up with the most basic fundamental units of dimensions to situate these objects. Consider all possible cylinders. You only need two dimensions. What is that? Radius and height. And you can create and generate every cylinder in the world. So given a bunch of cylinders, and disentangled representation learning algorithm will figure out radius and height. Okay, that's the disentangled representation learning. And we apply this to patents. And ideally, patents will now reside in an interpretable vector space that characterize patents by their canonical factors of innovation. This is what we are attempting and we are prototyping. Disentangled representation learning is still a developing field, and what we have is not perfect. Okay. Ideally, and when we do this, computing patents, for example, you do this and it may reside in dimensions like security, human-computer interaction, things that are canonical factors of innovation. Okay. Human interpretation still has to be added. So here's a visualization of innovation space from Innovae. Let's say just 3-dimension. Its axes are encouraged to be independent and interpretable, factor 1, 2, and 3. And it situates the patents in this vector space. What is different here, the directions in innovation spaces are meaningful. So patent B here has increased factor 2 and 3, whatever that may be. Factors are encouraged to be distinct, and it's not possible in any other approaches like TF-IDF or latent differential allocation. They lose the nice semantic features. So I'll talk about some examples. So what you can do now when you have this innovation space of patents, you can sort of characterize firms and have firm embedding and situate firms as well in the innovation space, which you can sort of imagine if you find all the patents owned by this particular firm and find centroid, let's just like represent that is like the location of the firm. All right, so good disentangle. Why should one care? The good disentangle representation. Once we have this, we can do control generation, right? So given a particular patent, we can try to increase particular factor and see what we get. And I'll show you an example of that. We can also do a lot of data-driven and unsupervised exploration at the patent level. I'll show you an example of some geometric interpretation of patent in the innovation space and identify creativity level. Second, we can do innovation factor level exploration. We extract factors of innovation that comprise particular set of patent group. And lastly, if we assume that firms are comprised of all the patents that they own, and it's obviously wrong assumption, but we can try to situate the firm in this innovation space. Okay.
So wait, I'm sorry. Can I ask a question? Oh, I'm sorry, Shane. Go ahead.
Yeah, go for it. Go for it, Neil. Yeah.
So if you can go back one slide. So I guess I'm struggling with, your sort of discussion of basically the embedding space that you're putting into, and certainly I agree that it's. A lot of the modern techniques, including embedding and neural networks, are effectively mapping things in high dimensional spaces, right? And one of the nice things is that those spaces often have some semantic meaning, even if we can't always figure out what it is. But there are also an infinite number of them, right? And so I guess I was a little surprised to hear you sort of in the next slide turn and start talking about this as unsupervised learning, right? Because of course we know that there are, a multitude of high dimensional things that you could map this to. So why do we think that the version, the one that you've done is going to have particular semantic meaning and that we're going to be able to parse out the dimensions that have that meaning?
Sorry, I was muted. So that's a great question. And that's a fundamental question to disentangle representation learning. In fact, ICML best paper says, this as I alluded to earlier, this approach of disentangle representation learning is still being developed. And there are some papers that show that, you need to actually have some inductive bias to actually extract out representation of data that are meaningful. So in the end, the humans also always have to intervene and interpret. But the technique that I'm using is a bit, it's more improved version of what's existing before because of its statistically encourage factors to be more independent and semantically more meaningful. Having said that, we need to have a domain expertise to guide the algorithm. And that's what we do. So I'm not saying our approach is like the only right approach. It's one prototype of it.
So will you say more about actually how, what you did on that process? Because it feels like that's going to be super important to us thinking about how to interpret the results, right?
Sorry, what was the point?
So,
Yeah.
so will you tell us more about exactly how you have, like, how you are both sort of pushing it in the directions that you think are more meaningful, and how you're going to interpret the directions that come?
Indeed, indeed.
Okay.
Slides
All
coming
right.
up.
I'll hold off then until you can tell us more.
Okay.
Yeah, then I'll hold off too. Keep going, Dokyun, and I'll come back to my question.
Okay. There was a raised hand.
Yeah, I had a question. I just had a question about kind of like how we should think about timing to innovate. So, and what I mean by that is, if we're mapping kind of past innovations, how should we think about when you're innovating, you're kind of looking at the world in a forward view. So something that doesn't exist and it'll exist in the future. Whereas it seems like the process you're going through is looking at all of the things that have happened in the past. So how should we kind of think of that as it pertains to like the process of innovating, or is there some adjustment you're making as you go through this process of thinking about this as kind of a predictive or a forward-looking process rather than kind of a view of the past?
Yeah. So this paper is just about characterizing patents and maybe coming up with some classification of how innovative it is. And I'll introduce what I mean by that, by representing. And what you're talking about going forward looking and actually maybe innovating, I haven't even asked. I mean, like I'm not working on that in this paper. I do have some ideas related to use of some, adversarial learning, but it's at the idea stage. That's what I'm trying to go into. But first, I need to represent the innovation. A very basic first step, so to speak. Okay, so all right, so what all right, still unconvinced, maybe, then good entangled representation. If we do have that, we're not guaranteed to have that, but if we do have that, we can ask and explore things like, what can you get if you combine patent A and B? How innovative or unusual is a particular patent with respect to specific technological factors, which is again extracted? What company excels in technological factor X? These are things that we can sort of extract out. If I'm firm A, what innovation do I need to boost up to be more like firm B? I can now ask these questions. Okay. So here's an empirical strategy overview. First, we prototype Innovae. It's a customized, semi-supervised beta variational autoencoder. This is what VAE stands for, variational autoencoder, trained on 240K patents, and we focus on a particular group for interpretability. Then we operationalize creativity of patents via philosophy of creativity and some geometric interpretation in the innovation space that Innovae extracts out. Then we also, it's all correlation and exploratory at this point, correlate patent creativity to economic and technological impacts using metrics from patent literature like forward citation and Kogan value. And we also then visualize and explore at the patent level, firm level, innovation factor level patterns. So entire paper is about prototyping and putting and situating patents into this vector space that we can do more exploration on. Results highlights, Innovae passes some sanity checks. We ran a bunch of them. Like interpretable factors of technological innovations are extracted, like security, human-computer interaction, and so on and so forth, because we focused on computing patents. And it's going to differ every time you focus on a different group of patents. Latent patent encoding improves downstream prediction tasks. So there is at least that we do improve some signal for a prediction task. And reconstruction of patent abstract look okay. And Innovae provides some useful signals about the value of patents I'll talk about, and more exploration into growth of different types of innovation, as well as innovation factors and firm technological composition. So these are just like highlights. I'll go more into that. Before I do, any questions?
Yeah, Dokyun, so let me ask my question, because it's actually a good.
Yeah.
It actually fits. So when I look at your list and how you got there, it's funny you don't characterize this as technological competition, and I'm wondering if that's deliberate or just is that where you'd want to go. So in other words, you should be able, it seems, the way you're speaking, to be able to define a cluster of patents for a specific firm and for other firms. And it seems as if you should be able to define something like a substitution between them, or an overlap, if anything, maybe not substitution in a economic sense, but maybe in a technical sense. And that would seem to be giving you benchmarks for technological competition and who's at a frontier as well. So am I misunderstanding, or is that not where you want to go?
So, wait, sorry, what was the direction that we were talking about?
Well, particularly, do you, it would seem like you could use this for characterizing technological competition. Who's on the frontier and who's leading and who's following? Just to make
indeed.
Just that simple question.
Yeah, that would be one application of this approach, and I actually do have slide related to that. So actually comparing firms based on their technological prowess, so to speak. It's exploratory, but yeah.
Okay, fine.
Great point.
Yeah.
Great. All right, so I will be now going into some theory and empirical methods. Well, I'll be talking about the variational autoencoder and how we change that, what we find that what Innovae gives a rise to, and we're gonna operationalize Margaret Bowden's creativity model. So first thing, why?
Can I ask you one more thing? I've got you.
Sure.
Sorry, before you get into momentum. Are you also going to be able to characterize when a specific firm has added a new dimension to the conversation? So
yeah,
who was the pioneer in a dimension? Are you going to be able to do that as well? Okay, so maybe I'll do this offline, but there is a literature that cares a lot about the economics of that. So we'll come back to that. Who's the pioneer in the technological space and who creates value and who captures it, and and why often the firms that are the ones who create the new frontiers are not the ones who end up capturing them. So that's a very, very large literature, as it turns out. So if that's your direction, I would think that's an interesting application. Okay, that was my point.
We'd love to talk to you more about that. That's yeah. Thank you. Yeah. So why generative models are required? So our model is a generative one as opposed to discriminative one. Discriminative one just models probability of some label given the X variable. Generative model models the entire data generating process, whether it's a probability of X or joint probability of X and Y, right? It's used to create model of real world instances. Of course, all generative models are wrong, right? Remember, the goal here is to categorize technological innovation with respect to their creativity level. That's the first thing. Of course, the first thing is trying to situate them and represent them. There's no existing Y-on innovation categorization, and you need data-driven approach to dissect patents. Trivial yet somewhat infeasible approach would be to gather human labels and make a black box prediction model, right? But this achieves nothing theoretical interesting. It's good for prediction model and scaling, and it doesn't dissect the patent concept space or inform us anything about the composition of what makes innovation creative. So as Richard Feynman alluded, to understand innovation, we have to start by prototyping a generative model of innovation. Of course, we're not saying this is the right model. In fact, this is a wrong model, but it's one prototype, and it's an exploratory one. So we use a disentangled generative model, as explained before, to decompose patents into independent and interpretable canonical factors. And our categorization will be based on these extracted factors. So first, we need to represent each patent as an n-dimensional vector. That's what we want to do. Here we choose the disentangled variational autoencoder for the job, because the data generating assumption and structure of the disentangled VAE is apt and controllable, as opposed to some other ones like generative adversarial nets. And this method has an added benefit of extracting out independent and understandable factors. So this is what we assume, that data generating assumptions of variational method humanity samples a random vector, Z, as an innovation embedding. And step 2, humanity then implements the concept vector into real-world instance, in our case, patents, right? So again, what I'm doing here is a vector space to which the model situates or embed patents are designed so that they're statistically more independent and semantically more orthogonal and relatively easier for humans to understand. And the way we do that is using and applying a method called variational autoencoder. A little bit of background on variational autoencoder. Variational autoencoder consists of 2 parts: an encoder that can embed document or numeric data into conceptual space, this innovation embedding space, so to speak, and then decoder that mimics humans to reconstruct the actual patents from this latent variable Z, right, as faithfully as possible. Encoder and decoder can be any sort of neural network, like multi-layer perceptron, LSTM, CNN, transformers, and so on and so forth. In our case, we use true LSTM network with customized loss function. So this is going back to the question asked earlier. How do you make sure that these things are more independent and disentangled? So variational autoencoder, without going into too much detail, is the first part. We have a customized loss function where the first part is a reconstruction loss. It basically makes sure that we are able to represent patents in a way in the latent space so that when we reconstruct, we're not getting garbage out. Right? So that this term ensures that. The second part is the disentangling inducement term. So the second term introduces disentangling or axis of the vector spaces to be as independent as possible. So the KL divergence term that pushes the encoder representation or the Z encoder representation or posterior toward the prior, which is assumed to be isotropic multivariate Gaussian. This is what induces a disentanglement so that they are more independent. Right, so this customized, this function makes it more like such that this latent variable of patent representation is more like isotropic multivariate Gaussian. And lastly, we add this supervision loss where the Y variable is basically some features of patent that we already know. And we all, like, in order to make it more realistic, we're telling, look, the patent has to have this Y variables. And so we are adding this semi-supervising term there. So think of.
I'm sorry. Oh, I'm sorry. Go finish your. Finish this. Go.
Yeah.
No, I'll ask a question, but finish your. You were going to summarize it, so that's fine. Do that first.
Oh, okay. So think of this VAE as some sort of a sophisticated nonlinear factor analysis. The differences and benefits are that it's multimodal in that it can incorporate both structured and unstructured data. It can do controlled generation of multimodal entity like patents. It can add supervision with known key variables like number of claims and things like that, and anything that we already know. And it encourages this entangled representation. Yes, the question.
Yeah. Okay. So this helps a little bit. So I guess I'm still struggling a little bit with why an autoencoder is the way to, or variational encoder is the way to think about this, right? Because effectively what you're doing is you're mapping down to a small number of clusters, right? And you're saying, and you know that you're successful if when you reconstruct, it looks like the words that are in your reconstructed pattern are not too far away from it, right? But that, effectively what you're doing is you're doing a clustering method here. And I guess I'm just like, why, there obviously are much simpler ways to do that, like k-means, or, just even think about putting it in a larger space. And so is it let me say it slightly differently. So I guess the thing I'm most worried about is you're mapping to all of these clusters, but we don't know that those clusters are sort of the dimensions we care about, right? They're independent because you push them with the beta variational autoencoder, but we don't know that they're sort of meaningful in the direction we want. So they could be like patents filed by big firms versus patents filed by small firms, or biotech patents versus tech patents or something else. And so, yeah, how should we think about that process of building those clusters and why this helps us do it?
Great question. So first question to address clustering. I don't think with the clustering method, you can do control generation. Let's say, for example, you want a particular patent to have a particular, more factors of a particular innovation factor. I'm not sure if you can do a control generation because there is no decoder to construct it, right? And second, you're right that there are a lot of things that are out of context of this algorithm that humans have, which is the out of context information and domain expertise. Think of VAE as a more sophisticated algorithm that you can add with a more bells and whistle, and you can actually add the supervision. So for example, you know a particular variable is important. You can actually incorporate that into part of the algorithm, which other methods are not. It's less easy or more natural. It's not native to the algorithms. Does that answer your question? I'm not sure. It's a more, to summarize, it's a bit more nimble technique that you can add more human domain expertise.
I mean, I'm not sure I agree with that. I mean, I certainly think in some of these high dimensional clustering things, you can say these are important dimensions, but I don't think that. So why don't I'll hold on more until you get to some of the results and we can talk about it. But I guess, I mean, the thing I keep coming back to is why should we believe that the clustering that this is implicitly doing in the latent space there is the clustering that we really care about for? I mean, I know it's more independent, but how do we know that it's the version we're going to care about for interpreting what patents are doing?
Yeah, so that's a fair point. That's actually a question to the entire field of disentangled representation learning. And actually, 2018 ICML best paper sort of show that you need to actually apply inductive bias to actually get something more disentangled. Disentangling is not possible without human intervention, is what that paper is saying. And so this is just a tool to add that supervision more naturally. And as going back to some clustering algorithms, I'm not sure how you can do control generation. Like, let's say you cluster something, you want some patents with a particular factor increased. I'm not sure how clustering would solve that problem. So,
well, I mean, you could go to whatever you could say, like, move closer to whatever the archetypical thing within that cluster is, for example. But anyway, yeah, that can be a discussion we can have offline.
Indeed. That clustering space also is the semantic space is not monotonic. If you go one direction, all the directions could be sort of fused together, and also it might not be as smooth. Yeah. So I'll show you an example. So data context is we use the G06 category, which are patents on computing systems, 240,000 patents between 1980s to 2010. And it includes things like PageRank and multi-point touch by Apple. And we use this data because it takes a long time to train these. We use the abstract. We could have used claims. We first started with brief summary, and that was like, no, it's not converging at all, like after like weeks of training. So we use patent abstract. The supervising things attributes are word count, number of patent claims, backward patent citation, engineer bibliometric originality, backward non-patent citations. And so some model validity checks. So I'm going to have to whiz through because time is running out, but I'm going to show you the abstract text reconstruction. Downstream predictive power is increased for some predictive model, and innovation factor interpretability, I'll show you an example, and that also show you the semantic structure of latent space. This is what this lacks in some other methods. So here's the first thing. Reconstructed text versus original text. Of course, this is original text about computer implements methods for use in conjunction with compute device with a touch screen display comprise, blah, 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 and so on and so forth. This is a reconstructed text. Of course, some grammar will be off. A computer implement method may include received by a computing device, an indication of a selection or portion of a touchscreen display. But we put some, we measure some token similarity with the Rouge 1 score, which is used in the summarization models. And state-of-the-art model does 40. We achieve 31. So it's some measure. It's not perfect. We also measure sentence complexity. The readability score of generated versus original is 9.1 versus 11.2. But more easier to understand is the signal value of this embedding. If the embedding actually does capture something significant, then it should have a higher predictive power in downstream tasks. And this is exactly what we test. We predicted Kogan value, which is a dollar value predicted from short-term market reaction of all the patents. We use numerical variable only. We get MAE of this thing, 0.8, versus LSA features and also LDA features. And our embedding achieves the best sort of predictive performance. So what this is telling us at the minimum is that embedding is capturing something significant for prediction. Here's a disentanglement. I'm going to show you an example of, example of what we extract out in this innovation space. So first thing what we can do is that we randomly sample a number of embedding vectors and alter the value in certain entry and use them to generate new abstract. And this way we can sort of figure out what each of these dimensions represent. There's no better way. It's not going to just algorithms. There's no algorithm that will tell you this dimension is X, Y, and Z. We don't have that technology yet. So it's the only way is we can actually experiment and extract out and interpret what these dimensions mean. Right? So we do this. Some entries serve with grammatical functions, and some entries correlate with semantic concepts that are particular to innovation, like security, human-computer interaction. And here is an example, innovation factors. So again, you can see abstract word count, non-patent citing, things are correlated with, but there are dimensions that are very specific, like human-computer interaction. It's described by a set of words, interface, control, mouse, text, texture, color, polygon, body, reflection, render, virtual. Things like security, check, authenticate, verify, malicious, authority, identification, protect, secure, signature, and integrity. So there is this limitation that human has to come and interpret, but I guess it's a blessing and a curse. First thing we also want to show that this space is actually meaningful, and one way to show that is in this innovation space, we can do patent fusion. So we can add two patents and try to get a new patent. So add latent embedding of patents, we can get fused patent and put this into decoder, and we can see what the abstract is, or actually we can find the nearest neighbor patents, and this is what we did. Here's some examples. You don't have to look into all of them. Let's just look at the first one. We take a patent A, which is this number. It's a method and system for customizing views of information associated with a social network user, combined with patent B, non-conformance monitoring and control techniques for an implantable medical device. And the nearest patent gives something, a concept to implement MedConnect, which is some combination of these two, right? Another example is if we combine some IT patents with the finance patent, like using multiple search engines to search multimedia data, patent, this number, and system and method for rapid updating of credit information. If you combine these, a nearest neighbor sort of patent would be process for protection against fraudulent use of smart cards and device for use of the process. So it's like search engine, method for rapid updating of credit information gives this fraud detection patent. So it's sort of what it tells you is that this innovation space, movement within the innovation space has some semantic meaning that we can interpret. We can also do control generation. For example, take any patent embedding and we jack up particular dimension that's related to, say, more security or more portability. We are able to get abstract that have these features with increased portability and security versus low, things like that. So we have more things in the paper, but multiple testing exploration seem to suggest that our model is acceptable. It's not the only way. A fair point has been brought up multiple times that it's just one way of looking at things. We need to do more testing to see if this representation is indeed good. Okay. So now I'm going to go into the fun parts of exploration into innovation space and patents and firms. Any questions so far?
So if I've understood what you're doing, in some sense, this next part is really what proves whether the previous part was worth your trouble. Right? So if you can get interesting insight about innovation space and competitive rivalry, then the choices you made previously would that would demonstrate that you made reasonable choices before. Is that a fair? Because it seems to me there are multiple applications, and you wouldn't necessarily use the same method for every application. But if it works in this application, that's proof of concept. Am I reading you right?
Indeed. Of course, this is also you're precise on that. And what I show here also requires some expert confirmation. What I'm presenting here is what I got from the algorithm, and further confirmation needs to be done. But basic stuff like, does the embedding have a more predictive power? We already shown that. So some basic stuff we already just shown that. And this is some more exploration, which it could be, it's take it as is kind of thing. It's always exploratory. So after furthermore, this is why I said it's an early stage and more confirmation needs to be done. But having said that, we are able to show something fun here. So, any other questions? Okay.
Yes.
Oh yeah.
More questions?
Yes. Go ahead. Hello?
Okay. So, I mean, do you have more slides to present, or should I? Then I'll wait.
Oh no, yes, I have slides, but yeah.
Oh, no, I'll wait then. No.
Oh,
not
okay.
urgent. I'll wait.
Yeah, we are now getting into the fun part. So I was like, that was like the chore of like presenting our model and some sanity checks. Now we're gonna use this to rank overall creativity of patents, and I'll talk about how we exactly do that. We have to start somewhere, and the guiding theory is the work of Margaret Bowden, which then was formalized by Wiggins later on. So Bowden proposes a categorization of creativity. So this is a philosophy of creativity that we're trying to operationalize through a notion of conceptual space, which can be described as a universe of thoughts from which new instance of concepts could be made possible. Right? So for human, it's a structured way of thoughts within framework, rules, and constraints. For example, sonnet is a specific conceptual framework or a conceptual space of poetry which allows for an unlimited amount of instances, which all have a characteristics of a sonnet. When we see one, we know it's a sonnet, but are nevertheless unique. Right? The same goes for a game of Go, which has more possible games than the number of atoms in the universe. And for machines, it's an algorithmically defined representation space, easily understood as embedding vector space, much like those created by our model, Innovae, or Word2Vec, or anything. Right? So Bowden's model distinguishes three main types of creativity, which are combinational, exploratory, and transformational. So the first thing is the combinational. It's the obvious combination of extent idea within a conceptual space. So for example, if you copy and paste different parts of different sonnet to make a new sonnet that makes sense, that's combinational. Or if you copy Go moves of a master and AlphaGo from different games throughout the game, this is also combinational. In fact, a lot of startup ideas are combinational in this way and pitched this way. For example, Y Combinator loves to present something like Uber or bicycle, or X of Y, Airbnb of whatever, right? So that's all combinational creativity. Exploratory is the next level. It's exploration within this conceptual space beyond simple combination. If you create a sonnet in the accepted form from scratch, this is an instantiation of what was potentially possible, but never realized, right? So this is exploratory creativity. same with the game of Go. Exploring a conceptual space means realizing things which hereto only existed as potentiality in this vector space, but was never instantiated. That's exploratory. Last thing is the transformational creativity, which is beyond the boundary of conceptual space. And it's breaking the existing rules and constraints to produce new instances of creative artifact. For example, people will say Cubism by Pablo Picasso is transformational, right? This may be coming up with a new form of poetry or game of Go or artistic style. And so these three levels of creativities are defined according to their relationship with the conceptual space and basically reflect how surprising, in our case, innovation might be. So it's exceptionality. And we operationalize this in a geometric sense within the innovation space. Sorry, was there any question?
Yeah, before you go on, could you just so you gave the example of Go as a way of thinking about the combinatorial part of this, right? So could you sort of take that example further? So what would it mean to do exploratory or transformational stuff in Go?
Yeah, so in Go, let's say you copy certain moves, right? And then you play expert, death and life and death, or there's like a copying certain moves would be combinational, but it's like a patches of different moves, right? That's combinational. Exploratory, you're just like literally playing a new game, right? A new game from the scratch. You're not copying any sort of predefined moves within Go. Maybe also in chess. Transformation will be just like coming up with the new rules, new game of Go.
Okay, so
according to Bowden.
So in this particular instance, like within the game of Go, there is no such thing as transformational. There is only combinatorial and exploratory.
Yep. Within a game of Go, yes. Transformation will be coming up with an entirely new game of Go. Okay. All right, so we operationalize this with using some geometric representation within this innovation space. So what we do is this. We first assume that all technological innovation could be embedded in an n-dimensional Euclidean space. And as a toy example in this figure, we can see a bunch of gray points distributed in the 2D space, each representing an innovation created before 2019. So let's now define two boundaries in the space. First boundary we call innovation frontier is a convex hull of this point within this innovation space. So basically any point within this convex hull may represent a potential innovation that could be generated via combination of existing technology. So as this embedding space represents abstract technological factors, any instantiation within this convex hull is conceptually understood as combination of existing technologies. So we call this combinational creativity according to Bowden's model. The second boundary is we call it conceptual boundary. It's defined as the minimal bounding box of the existing point, and it's an axis-aligned smallest box that contains the convex hull, right? So going outside of this minimum bounding box conceptually means the patent was instantiated with attributes of factors of innovation that has never been imagined possible within this conceptual space. This also incorporates creating a new orthogonal dimension. Perhaps imagine orthogonal dimension coming out of the screen, right? That's also outside of the minimal bounding box. That's tantamount to creating a new factors of innovation. It's captured within this model. So given these two boundaries, we can identify the creativity type of patents by examining the topological relationship of the idea against these boundaries. For example, what we define or operationalize here, there's 7 new points here. If it's within this convex hull, the orange points, we'll call that combinational patent. If it's outside of the convex hull, but within the bounding box, we'll call that exploratory. And outside of the transformational, outside of the bounding box, we'll call that transformational. I cannot visualize this, but it also tantamounts to a point that's coming out of the screen, so to speak.
So Dokyun, so that's interesting, and I'm very interested to see how that plays out. An alternative, I would have thought, would be the addition of a new dimension would then generate different definitions for exploratory and transformational. And are you going to go down that route also, or because all of this is working within the space? Yeah.
Yeah, you're correct. I think so. This is like it has to be defined within year to year, right? So you take whatever came before, and then you're able to define what is exploratory, combinational, and transformational. So it depends on what came before. You're correct.
So can I also ask about, so if I think about what you told us, the way you define the embedding space is for the properties of the words that are in the abstract of a patent, the number of claims that are in it, and a number of other features that, right? And so effectively then, like what this is going to mean, like the convex hull, for example, is going to say, like, if somebody uses the word quantum way more times than anybody else has used it, right, then it's going to be outside of the convex hull, because it's going to be like that would be an example of something where no patent has used the word quantum that much before. Or if it's the very first patent that uses the word neuromorphic, that's going to be transformational, because it's going to be out of the plane of the things that have come before. So
in a sense, yeah.
Well, okay, so that was precisely what I wanted to ask. So like the two examples I just gave seem like things that you could also capture with just sort of new words appearing in the lexicon, right? Or sort of word count models. So what else is this model capturing that I'm not thinking about when I think about that toy example?
Yeah, that's you're asking the right question here. It's hard. So whenever you're using this sort of new word that's appearing, right? You're always creating this ad hoc space of the new words. In this VAE, what it's trying to do is it considers all the words that came before and the new things that are appearing, but does it in a meaningful way. It clusters, like, so to speak, it's not really clustering, but it combines these words in a meaningful way to come up with factors. That's the only difference here. So the space that it creates, the innovation space as we call it, it puts everything, it considers everything in relation to one another, such that the distance between these points are meaningful. It is meaningful that in LDA space and TF-IDF space as well, but the space is a bit more, I would say, ad hoc. I'm not doing a good explanation, a good job of explaining here, but the fact that the additional constraint of making each of these dimensions more independent make it more easy to control the generation of these new factors.
Okay, I know you don't have much time left. I'll ask you more at the end.
Okay. All right, so after we have considered using, we come up with some classification of creativity. We then correlate this to different things like growth patterns. First thing is we see that combinational ones experience a stable exponential growth compared to, say, exploratory and transformational. You can also see that creative ideas get relatively more scarce. In 1980s, every 3.6 combinational innovation come with one exploratory and transformation, but that number is increased. This is reminiscent of some papers that I'll discuss later on. Like recently, the Stanford people have wrote a paper, "Our ideas are getting hard to find." It's reminiscent of that. First thing, the next thing, we also correlate this to 10-year forward citation. We see that combinational 10-year forward citation of the combinational invention is significantly lower compared to, say, exploratory and transformational. So average number of received forward citation is lower for combinational. As opposed to this result, when we correlate this to the Kogan value, which basically tries to calculate the value of patents using short-term market reaction, we see that combinational ones have a higher value, dollar value, compared to, say, exploratory and transformative. differences are significant, but this is perhaps due to the Kogan value because it uses short-term market reaction, right? Maybe if we incorporate the longer term, it'll be different. But all of these are just exploration. But what I want to get more into is this farm level exploration. What we can do with this within this innovation space. And what we can do is precisely characterizing firms by their patents. So within this space, let's collect all patents owned by a firm F and then obtain the average patent latent embedding, then use the Innovae decoder. What we can do is fun stuff like this. Firm and their synthetic representative patent abstract, right? So you can see, well, we have just chose ones that everybody knows: Apple, Microsoft, Google, Samsung, Adobe, Ford. This is just like a representative synthetic abstract by combining all their abstract and then making them produce abstract. We can always do this with claims, brief summary, and anything. So you can sort of see Microsoft, a portable computer system, have a screen and a keyboard for use with the computer system. The main body have a display portion and display portion. Of course, it's somewhat grammatically incorrect, and all of these things are rough. The keyboard has a plurality of key, which is associated with the key of the keyboard. The keyboard be arranged in a manner that be transparent to the user. So you can sort of see Adobe is their main thing is method for controlling the operations of a printer. Ford is a method for controlling the operations of a motor vehicle. So this is an example of what we can do. Another thing is we can also figure out the nearest patents. Given their location in this innovation space, give me 3 nearest patents. We can also do that. For Apple, portable electronic device with the interface reconfiguration mode, user interface widget for selecting a point or range, user interface for providing consolidation and access. Let's just look at, say, Samsung, a method for protecting user data in a personal digital assistant telephone. So this is one thing we can do. We can also figure out which patents are closest to a particular characteristics, innovation characteristics of a firm, right? So here are some examples. I'm not going to go through all of them. And what we can also do is this. We can come up with what we define as an innovation index is this. It's an innovation index given patent X, innovation index I, we define it as an absolute posterior mean and prior mean at dimension I. So technological factor dimension I. So high index in this means the patent is exceptional in this technological factor. Low index means the patent is average in this factor, right? So what we can do is this. So now we have extracted these technological factors using G06 computing patent. We extracted these technological factors like, right, human-computer interaction, automation control, finance and transaction, connectivity, document processing. I showed you an example where these are described by a set of words. We can also then figure out innovation firms that are high in this innovation factor. For example, in human-computer interaction, within this 1980 to 2010, Nintendo was the highest in innovation index. Right? We can also see that Pixar is pretty high, followed by Emergent, I don't know this firm. In automation and control, Toyota, followed by Intertrust and Silicon Motion. I don't know some of these companies, but the point being, you can actually rank firms based on their innovativeness and exceptionality in a particular innovation factor. You can see that Visa ranks top in finance, Wells Fargo, connectivity, document processing, Fuji, NTT, and Dell. Right? So these are some of the things you can do. We then also visualize, and we can also situate firms in an innovation space. I just took like 2-dimensional projection. Again, this is more like a 30-dimensional vector space, but let's just take 2, human-computer interface and document processing. And you can situate them and then come up with the distance. You can see Apple, Google, Microsoft, JVC. You can situate them. What this enables us to do is actually we can figure out the distance of different firms within this particular innovation space or factor. And what happens if you want to go closer to particular competitor firms. Right? This is another example with the finance and transaction on one axis and automation and control on the other. You can compare and contrast. These are some companies that we all know. Any questions so far? I've been just like whizzing by. Yeah.
Yeah. Does this predict better than the Kogan stuff? So if you knew a firm was leading, does the fact that you know they're leading, because it's a combination of things, right? It's coming from both combination of the patents and from position relative to rivals. So it's coming from multiple areas. Does that give you more information than Kogan's estimate, which is one patent at a time based on, right?
That's a great point. That's actually on our queue. The output variable would be firm performance, and we want to, the X variable would be Kogan and forward citation versus our representation is in the works. Thank you. Any other questions?
Yeah, I wonder if you've had any thoughts to tracking this over time.
Yes. This is great. Yeah, precisely. I think here's an idea we had. We have this over time, right? And we know and we can interpret each of dimensions. What if we measure variance over time, right? We can see the rise and decrease of particular innovation factor. That's another idea we have that we're trying to implement. Yeah, so we want to also see, even before that, we can also map this per year, how actually each firms are moving across time, right? That's what we can do. So we are also looking into that. Perhaps like Google gets closer to, I don't know, Oracle over time. I'm just making this up. But that's exactly what we can do in this space. That's not possible in clustering or some other space where movements within that space it may mean something, but it may not be independent. It's what I'm saying. And this one is a bit better version of that. It doesn't guarantee independence, but it's just a better tool for doing that.
So DK, how do you think about this? This gets at Shane's question a little bit, which makes that a harder estimation to do in terms of firm value, is that many patents might be not valuable on their own, but when connected with other patents are, or they're put in just for like patent thickets or some defensive purpose. And in that sense, they might show up on these dimensions as very not valuable, right? As low value. But when you weave them together, they're quite high value.
That's a great point. I think what we can do is if we have like external measure of that, like Kogan value. I know Kogan value suffers from some issues, but let's say we have like versions of that. We can actually include that in this model. That's like sort of a semi-supervising model so that this space internalizes this valuation, right? So what you can do is, what this will do is it'll come up with the space where the canonical factors are arranged in such a way that if you go in a particular direction, it's more valuable. So it can internalize that. Does that make sense? I'm not sure if I make sense.
Yeah, it would have to take some like joint thing into account, right? Some kind of.
Yeah. It will have to use a different measure coming from human expertise, but it can internalize that is all I'm saying.
Can I jump in? Lauren, that was a great question. You articulated better than what I was asking. So it's great, but it then generates a response. So one of the things that's happening in the era that you are examining is the courts decide in the late 80s, early 90s that software patents are valuable. And it's this trend that emerges. It's quite independent, right? Shows up. And then the Supreme Court gets involved and approximately a dozen years ago to the present, starts to systematically diminish, right, with a series of court cases, the value of software. So to Lauren's point, that would not show up in a Kogan necessarily well in a Kogan estimate because it's often about the holdings of the firm, not the most recent patent, right? It's about how the patent holdings of the firm, the stock, if you will, and the combination of that stock with the various things, their values are going up and down based on court cases and legal cases. Whereas the Kogan thing wouldn't see that because it's only based on the immediate reaction to a particular patent. So building on Lauren's point is what I'm trying to say, is building on Lauren's insight, which I thought was a great question. Couldn't you also trace the changing value of having a software leadership position, and then both the rise and the decline in both directions?
Yes, indeed. You can. That's one of the good part of the VAE, that you can actually incorporate that additional data naturally, so that this space represent that. Also, I got rid of that visualization from this presentation, but I have this exact same visualization where it's a heat map of Kogan value in patents and firms. So that sort of visualizes what the data is saying. It's a reflection of the data. So you can incorporate that. It's not going to be like, here's the right, correct way, but it's just basically a good visualization of what the data is saying. So we can incorporate that if we have additional data.
Cool.
Yep.
But can I suggest, I think you could go even further with Lauren's suggestion, because implicitly what you would say is, like, if you have a model where every patent is independent, you could sort of say, you could draw the patent in your space, right? And you could put some sort of sphere around it, which basically says the patent scope that it has on its own. And you could say, okay, that, if a patent has a certain amount of a scope, you would expect nobody to be too close to it, right? And you could sort of look and we see if any other patents arrive after it that would be in that space. But I think Lauren's question, the really powerful thing that you could show potentially would be to say, if you have this patent, and this patent, and none of them on their own seem to cover some space in the middle, but collectively nobody goes in the space between them, sort of says that having those three patents effectively annexes that whole space, right, in this high dimensional thing. And I think that would be an example of saying, oh, look, by having just those few key patents, you have annexed all of this, and that probably creates a lot more value than you would expect by just looking at the patents on their own. And I think you could see that by just seeing that nobody arrives in that space after a firm has them, even though you might predict in other ways it has a lot of value.
That is very interesting. So I can actually come up with a measure of the volume spanned by a particular patent owned by a firm, and then sort of turn that into a measure. That's a great idea. I'm gonna, thank you for that. I haven't thought of that. Yeah, that's a great point. Yeah. So I'll explore that too. Thank you. Mm-hmm. Thank you, Lauren, Shane, and sorry, what was your?
Neil.
Yeah, Neil. Yeah. Thank you. So any other questions? These are great. Thank you all for this cool ideas. Okay, all right, I'll continue. So considering this our preliminary result of prototype within the context of Econ of AI, we echo highly discussed path towards AI augmented invention to increase productivity, right? So Bloom et al., the Stanford folks, present evidence from various industry, products, and firms to show that research effort is rising substantially, while research productivity is declining sharply. A good example is Moore's law. The number of researchers required today to achieve the famous doubling of the computer chip's density is more than 18 times larger than the number required in the early 1970s. And this is explained by multiple different scholars over time. And this is largely due to different effects, such as low-hanging fruits are already discovered, easy ideas are already implemented. There's also this burden of knowledge where you could stand and, go forward in the shoulders of giant, but it takes a lot of time to, climb that giant, right? So Jones has talked about that, the burden of knowledge. And there's this also idea of a curse of dimensionality. So where if, the vast knowledge is just getting so quick, large that one has to actually focus in a particular dimension or a particular specialty, and that precludes this expert from connecting the dots, so to speak, and coming up with the creative inventions and so on and so forth, right? So all of these together argue that as technology progresses, the innovation frontier increases, and the amount of knowledge required by one individual to make innovative breakthrough gets harder as they need to learn more and specialize in a narrow subfield. It leads to a combinatorial explosion of combinational innovation. So thankfully, Econ of AI posits and argue these latest some essays and papers and research papers show that deep learning as GPT general purpose technology, not the GPT-3, and invention of method of invention can perhaps improve performance in existing search intensive research projects, because it can you can imagine it automating this combinational innovation, right? And find useful combination in complex discovery space. So this was posited before by all of these researchers, and we have actually just shown with this prototyping that you could do something like that, in fact. And our results seems to support this conjecture. Of course, the ultimate question is, can an AI do transformative creativity, right? I don't think anyone in the world can answer that. That's where I think that's getting close to somewhat, the strong AI. But there are some ideas that I had related to adversarial training of this. Anyway, so here is just, I want to end this presentation with some example. Here's a 2019 patent by Schick et al. It's basically a patent that can create a draft of patent to be filed given human inputted patent claims. So they have this and they're commercializing this, which is amazing. But what I want to end this presentation is with generative models still needs a lot of work. The VAE, variational autoencoder, and disentangle representation learning suffers from a lot of different issues engineering-wise. So for example, posterior collapse, disentangling is an unsolved problem. It was brought forth by Neil that, this is, how can you be sure? That's another open question. There's also training issues on realistic instances coming up. And some of these things that are generated are meaningless. That's why human interpretation is always required. But with much engineering and sort of semi-brute force way of approaching this and injecting domain expertise, current algorithm, I claim, should be able to provide a subset of useful concept of non-existing patent claims, which then you can put it into this algorithm and come up with some invention. But I do think that what we can do currently is all combinational. So main takeaway is generative model can reveal insights about patents or innovation by situating them in this interpretable innovation space. This approach enables more exploration. Many people have already given a lot of ideas, cool ideas. Firm comparison valuation purely based on their patents, which is wrong assumptions, but you can go somewhere with it. You can explore evolution of innovation. You can also sort of automate industry classification based on what they own, right? And the descriptive evidence show that combinational innovations experience an exponential growth, which is alluded by this innovation literature, while innovation with superior creativity, such as exploratory and transformative innovation, remains steady. And lastly, there are a lot of new possibilities brought forth by this generative approaches. Imagine using Innovae or this approach in job listings, right? You have all these Glassdoor job text listings. You do this exactly same thing. You're going to situate job in a skill space. You can see how skills evolve. You can see the future of work and explore that. Come up with the best combination of skills and define a new job or things like that. So what we are proposing here is we should explore generative approaches in business. And that is the end of the talk. Manuscript is coming soon. Please contact me. It's going to probably come within a few weeks. Thank you for coming. Any questions?
Yeah, we got time to have a little discussion. It's great. I mean, thank you very much. It's great.
Thank you. The audience has I appreciate all these ideas. It's great. Thank you.
So this is fascinating. Okay, so now I've waited with few questions. So
Yeah,
first
sure.
of all, yes, this is fascinating. And also I didn't know you were working on it, and I'm so happy because I have some work that just started looking into it and I felt completely alone. So it's so great to see others that are exploring this space. I think it's a whole new space and there's a ton of room for a lot of different approaches. And the part that I was looking at was kind of experts, crowds, and AI, and the different contributors that can bring to the game and redistributing it. But I can see also just looking at AI, and as I said, I just came today from actually a discussion in the Open Innovation and Science community where people were debating. I kind of brought up this topic, and there was a debate whether and should, and that Lauren was surprised even that there are people that think against it and to which tasks. So if we take kind of talk to the higher level of what today. Let's say in the next 5 years, based on what you've played with and you saw kind of the specific technical capabilities, since that's what I think I've been puzzled with in the last, let's say it's been 3-4 years that I've been looking into this, and every time the technical capabilities are not where we think they are, and then some of what we imagine doesn't necessarily happen. So I was curious to hear from your perspective on the technical capabilities. Where do you see it's going? Do you see it still like kind of more basic research? Researchers will look into it, something that could be applied by companies, could be tested. Is it more to understand innovation, as you said, to really understand these things and play with it? Or the generative part is kind of maybe later? So where do you think things are happening?
Yeah, so I think question, if I understand correctly, is where do I see this generative models being used to innovate or create? Is that or
yeah? Also, the technological readiness level. Like, what's the technological readiness level you think of such things? Are we just now from like era of ferment experimenting with such models? But there, it will take 5 years to have something that can really work.
No, I think given the data in the field where we have a good record of data, we are able to we are seeing science. I read some Nature and Science papers in material science and molecule and chemistry and physical chemistry where they're actually applying these generative models. Some of them are using just scans to come up with the combinational, what I mentioned, like the combinational innovation. There is a paper in material science that basically went through all the scholarly articles and came up with the new molecules that they were going to come up with. So that's like at the level that we are at now. And these Stradinger, they're using physical engines of the model as well as generative model. What they do is a framework where they generate stuff and then they put it into physical engines model, which is totally just done by some rule-based, and then see if this is going to work out well or not. Then what they're doing is to try to come up with candidate molecules that might work against cancer or good molecule for battery. So it is going on. And Atom-wise, I think it's in Boston. I think they started in Boston. And they're doing this right now. And if you see this set of papers that are using combinational innovation and use of generative models and AI, this is all like within 3 years. Like you go back, this is all within 3 years, which I think we're at this cusp. Now, to jump from this to like exploratory and transformational, I think I don't know how one would do that, but there may be some way. That's what I'm trying to work towards. I do have some like prototypical ideas on how to do that, but let me first finish this. But I think we are at this like golden age where it just started. Like everybody is working on this, and it's all within within 3-5 years. And before that, I haven't seen these papers, but it's all popping up. So I think within few years, I think people will. You can see that the patent that I just showed, the generation given human-generated claims, just like coming up with the patent, that was 2019, right?
Yes.
So I think within 5 years, a lot of commercialization will happen. And I see a lot of private equities going into this.
Okay. I had your optimism 3-4 years ago, and it has been more. I've been more conservative ever since what I've seen. But I'm happy to hear that that's how you think, and we can talk more offline. And if you have time with this discussion to share a little bit about the adversarial approach that you're thinking for the generative AI. That would also
Sure.
be fascinating to hear.
Sure. No, I do share your sort of reservation. I think we're still at the very beginning stage. That's why this paper was about representing, not creating, right? So I'm not claiming anything. It's about the creation. I'm just like, I'm having a hard time representing it. Okay, so representing is a hard problem to me. So having said that, I think a lot of things that what I think is optimistic about is this. So CS folks and statistics folks have been coming up with these cool tools, useful tools. Coming up with the tools that work all the time is super hard. But what we can do in a domain with the domain expertise, we can just like brute force using this tool and do something cool, right? It could be combinational, it could be somewhat marginal at some point, but that's what I'm hopeful about. And there are a lot of room and value there as well. I don't think we're at level, and I don't know if anyone, I don't care if you're Jeff Hinton or Benjo, I don't think anyone knows where the AI is going next 5 years. If they do, I would not trust this person. But at least at this point, I think this combinational, we have seen enough evidence to be hopeful.
Definitely the areas of pharma and components. So I fully agree. These are the two areas that have been flourishing that I've been seeing. It's in the other stuff that are based on patents that I haven't seen enough progress. That's what I meant. But on compounds and on pharma, basically, which is like compounds for pharma and chemicals, I meant, that's where I've been seeing kind of the growth. I've talked to even for a few companies that are already implementing it, and it's really interesting. So that is definitely taking place. But the rest, like what you're trying and what I've been also looking into the patent base, that sounds still hard to do. But maybe that's why it's great to see others working on it. I don't want to take too much, and I'm sure we'll talk more. So if there are any other questions, and at some point, if you still have time to talk about the next approach, would love to hear that as well.
Yeah.
And so if there are no questions, Hila, but I want to follow up with what you're saying. Even in other places, like I think the question is still out there whether, like incrementally, we can come up with a new molecule, but will those be valuable molecules, right? Or will these just be incremental add-ons? And so it's unclear whether it's helping us come up with.
And no one is willing to answer that question. So if anyone has a real answer from an R&D manager in pharma, I've been chasing them. I think Frank has heard about it. Like anyone that I know, I was like, anyone in pharma is willing to tell or to share. But it's the same thing that was like years ago with other things, and also AI and HR. Many managers are not sharing what they're doing, and they are doing it. So I think it's still the area of experimentation, and they're throwing darts and whatever. I don't think there's any systematic findings around the value of it, but it's definitely being used. I talked to ExxonMobil on the chemical side. That's the only company that I was able to like really talk. All the R&D pharma, the rest are just saying, oh, it's great, we're investing. But I see a lot of money being poured at it. So doesn't mean everything, but it means something. But it could also be COVID related. It's like a hype. It could be a COVID hype also.
No, I think at this point, only things that are sort of valid and shown to be proved to be useful is just like, it's good as a generator of ideas, and humans have to always filter out things. It's augmenting. So I've seen some examples. Some colleagues of mine they implemented design with the generative model. And of like augmented designers, the car design, Alex Burnham at Yale, and John Hauser, and Timoshenko. So which is, I think, a very cool idea. But we are all like, I think we're all in agreement that it's a good tool. It's a good tool to generate things like combinational exploration of what humans have already created. Now, going beyond that, that's the question, right? That's, I think, intellectually. Can we even do that? Or what creates that? I mean, we are doing that, so it must be possible. How can AI do that? And I think the closest idea to that is perhaps there's a generative adversarial network called CAN, Creative Adversarial Net, and it's able to actually create new field of art. And it comes down to basically random noise, and then it's just creating random stuff and then filtering things out. So it's this, I think in a sense, that's what we're doing too, right? So I don't know. I have to explore more into that, but that's fascinating to me. But you're right. I think everybody here already mentioned whether it's correct or not, this new molecules that are available or not. That's another. That next layer is required. Schrodinger, for example, uses generative AI, but then they have their own physics engine model that they built up for decades, over decades, that they then input this and then filter things out. Then they, show to Takeda or companies like Bristol Myers that they have a relationship with. Here are molecules then you might want to try. And so they're just like reducing phase 0. That's all they're doing in drug discovery.